Hello guys, welcome to our training today. Today we want to understand the RSA encryption algorithm, which encryption and decryption algorithm, which is one of the asymmetric keys. So we're going to use RSA to do an encryption, and I'm going to use RSA to do the decryption. So encryption and RSA is nothing else than is the modulus of the plain text that I want to do raised to a factor of E, and E I will explain later on is a generator. Mostly mathematically it's a co-prime of P and then Q, where P and Q are very large prime numbers, or for N. So we have N, which is the modulus, which is the composite number. It's just nothing than just a multiplication of two large prime numbers to get that. And then you compute E, which is the co-prime. So co-prime are factors of the prime number which are only divisible by 1. Okay, then the reverse of the RCA will be to take the ciphertext and then take it to an exponent of D, where D is the private key but N and E are the public keys. Then you take the mode of N of that, and then you get that. To compute D can only be computed with knowledge of the two prime numbers which are private to the person generating the key set. Okay, and the public is only aware of the N, which is the product of the prime numbers. So it is said that it is very easy to multiply numbers to get a composite number, but very difficult for computers to do factorization to find the two numbers P and Q that were multiplied to get a composite number. This is what is relying on. Okay, so we'll use Replit here to do the various computation, and then we'll be using BC. BC is an operation within the Linux box to help us do computation. So we'll start with the first one. So in the first one, for example, that we are given that the plain text is the plain text is 4 and the N is 33 and E is 3. That means that 33 and 3 are the public numbers which are basically shared. So to compute the ciphertext of that, we will take the 4 exponent 3 modulus 33, and then we'll put that in here. And first let's get BC. So just choose BC, install it. It's going to start. So we can now paste BC is running, and close this one and close that, and there we are. So when we compute that, we have 31. So 31 then becomes the ciphertext which is being sent across the network. And once we have 31 being sent, that means that the ciphertext is 31. So at the receiving station, it's going to take 31 and then basically put 31 here, and then compute the D, which is the co-prime of the modulus of P minus 1, Q minus 1. In most cases, D is given in our example here that consider D to be 7. So we're going to put 7 right here, and then we compute the modulus of N, which is N is also globally known as 33. So we put 33 right there. So we can just copy the whole of this text and then paste it in here, and then holla, there we have. So we will paste this over here, and we can quickly just close the brackets up. Okay, and close that, and we compute. You see we get a 4 back. So here we are being able to use RCA to encrypt a plain text 4, which is the symmetric key for exchange, for example, in an unsecured environment. And then we got a ciphertext 31. We sent it over the network, for example. The receiver got 31, and with the knowledge of the private key, which he only knows as the two prime numbers that were basically multiplied to get a composite number, took the co-prime of that value, he's able to get the E of that and the D of that, and it's just a multiplication of this. In my next video I'll show this, and then he was able to get a plain text back. Similarly, so that's for the number we've decrypted it. So let's pick another example. So in our other example, we're going to have that the the public key is 55 and 7. That means that 55 is N, 7 is E over here. Then let's say we have plain text A to encrypt. So we take this and then we 8 exponent that to 2, paste, compute. Oh, sorry, we have to input modulus. Okay, so percent sign, and then we have 2. So that is our ciphertext is 2. As we take 2, and that will become the ciphertext that we sent across. So upon getting to the receiving end, we then take the prime number that we have given, which is 23. I already explained to you that 23 can be computed with knowledge of the 2 prime numbers. We can go ahead and then compute the modulus. So in decryption, we take Y, which is the ciphertext, to D, which is the private key, which we have been given over here, to a modulus of N, which we already know. So once we put this into place and paste it in Replit with the BC model, BC calculator, I'll calculate that. And here we are, we got the ATAC. So we took a plain text and then we encrypted that with the knowledge of the public key that we were given, and then we got the ciphertext, took the ciphertext with the knowledge of the private key. We were able to do the modulus of that and then get this back. So that's all for today. Thank you very much.